It seems like you really make companies safer, smarter using graphs and the tech behind Neo4j. So if you've never touched graphs, perfect. We'll keep it simple and practical.
Yes.
So I guess maybe to kick things off, what is a graph in the context of AI in plain English? Let's start there.
In plain English, I like to go with what people know. So when you think about your social media feeds, whether personal or professional, you and I are now connected on LinkedIn, right? And each of us have different connections. And so if you imagine, we always use circles and lines between them. So in a graph, it's really an entity or a thing and how it connects to another thing. Very simple.
Simple
and
as
then
that.
just all those little circles and lines connect together to show communities. So if you think about even your community where you live, you know some of your neighbors, but not all of your neighbors. And so if you just sort of map out those connections, that's what a graph is.
I love it. I know. I think it's been easier for me to understand. I think my brain always thought about graphs and connections visually.
Yeah.
So I have thought about how, in general, folks who think in that visual realm, it's probably easier to think about graphs from that standpoint.
Oh, definitely.
I guess for the folks, I'm curious, maybe giving examples of everyday problems that graph solves can help, ground it in reality for folks. What could be some examples that come to mind for you?
Have you ever used GPS directions? Your Waze, your Google Maps, your Apple Maps, especially if you think about when it offers you the option for different routes. So you may have a route that's optimized for speed. You may have a route that's optimized for mileage. You may have a route that is more scenic. And so pathfinding is a really common one, and that's one that we use all the time. When we get into the business realm where it comes in, you'll see things like fraud detection. So for example, one of the elements that you can look for is you can look for like circles of interesting connections. So I worked on a project last year with Syracuse University called Election Graph, and they were tracking payments for advertisements in social media, Facebook, Instagram. And one of the interesting things that they found is when you actually tracked the entities who were putting out these advertisements, you could look, and if you looked from the outside, it would look like they were all these different separate entities. But when you started to connect email addresses and phone numbers and addresses, you actually found that there were many seemingly independent pieces that were all actually one base entity. And you wouldn't know it, because if you think of it from a tabular perspective, you could say, oh, these two rows share a phone number, and then these other two rows share an email address. But when we actually start connecting them, what you find is you have two entities that share nothing in common, but because of those connections of email addresses and phone numbers, they're actually still all part of the same entity.
Right, like it had to exist in that graph perspective where in some ways you created new knowledge because the connections are new knowledge that wouldn't have existed in the tabular format.
Exactly,
and
that
so,
multi-hop connection
right.
exposed something really interesting.
Because there's like an aspect of just matching on the content piece, but then there's the matching itself is data that the graph enables in some ways, so that's kind of cool. Also, this is kind of fun when you're talking about finding the fastest path. It kind of reminded me back to college days where I learned Dijkstra's algorithm.
Oh yes,
and I was like, oh my god, right? Yeah,
I use that one all the time.
I know, it's such a throwback to graph theory days.
I mean, and that's exactly what it is, and what I find the most interesting about graph thinking. I'm like yourself. I think I'm natively a visual and a graph thinker, and so for me, it's always been how I navigate the world is in graph. And I was going to say something, and now it went away.
It's okay. Well,
sorry.
I'll give you one other idea
up.
that I had, now I think about it, I should just build this because we're at a build-a-thon.
We are at a build-a-thon. What are we building this afternoon?
So I've always had this vision for, there's Google Maps, which gives you the perfect shortest direction. And if they've optimized it towards being efficient to drive on the highways or whatnot. And now they've added this idea around EVs. Now, but what I love doing is I love going on road trips and adventuring and just exploring a place. And I want a path that's the most interesting path, the most aesthetically beautiful path. So why not create a new navigation system that optimizes for some of these other qualities that we may look for as humans.
Oh, I would love that.
Right?
I mean, how I would do it is I would be really interested in leveraging like Instagram landscape density.
Whoa.
To use that as, of course I just go right there, right? I'm like, oh, let's use Instagram where there's lots of landscapes and, we have that. I'm really interested in what I call AI gravity. So that's that type of thing. And so that could be one way, because how do you define interesting, right?
Oh, wait, yeah, tell me more. What do you mean by AI gravity?
So something that's really interesting to me, and when we think of complex systems and we think of data, if you consider, everybody's probably built a RAG application at this point. And if we think about just that one use case, if we looked at the documents that are used the most often, the documents that lead to the next document, and that volume of use creates what I call AI gravity. So it's an area where there's a high concentration of data use, or in agentic systems, high tool usage, or if we look at when all of your AI ecosystem is connected, which pieces are the most influential across that complex system. So that's one of the things that's really interesting to me, and where my personal research goes is into really understanding those gravitational pulls from that data perspective. Because most of the time when we think of observability, we think of governance, oftentimes or even risk, we think in snapshots.
Right.
And the physics of the data flow, the physics of the tool usage, the physics of, risk increases or decreases depending on context, that's the part that I'm really interested in, is what we can find when we look at it in this temporal live perspective.
Yeah, no, I'm just like, so many things got unlocked when I think about it that way, right? It's another dimension to data at the end of the day, which is the temporal aspect of usage. And I'm even thinking, again, I know in a graph, but in that three-dimensional space where the usage and how the usage connects in various ways to other things.
Yes.
So yeah, that's fascinating. Well, I guess kind of building off that, a lot of folks have heard about RAG and a lot of times tune out when you really start there. But I'm curious if you can explain what GraphRAG really means, and because I think that's one of the core aspects for Neo.
Yeah, it's one of the places that we've seen, in the generative AI era, that graph has actually found its way into people's toolbox, right? And it found its way into people's toolbox because, for folks who may not know exactly what retrieval augmented generation is.
Let's start there.
Let's start there. So retrieval augmented generation is generation. So you think you're connecting to your LLM, your ChatGPT, but we need to ground that in something factual. So we want to augment the generation, have it not come from just from the LLM, but have some facts that goes with it. And so it packages those facts together to generate that answer, right? So that's what retrieval augmented generation is. And that's where all of our chatbots started. And the way that it works is, not to get too deep into the math, but really what happens is when you write out words, we have something called vectorization or embeddings. And what it does is it creates a very long string of numbers that represents sort of where that topic lives in space, right? Just easy way to do it, right? So if I ask a question about, I don't know, yellow labs. I love my yellow lab. And let's just say I have a question about how to train this dog Goose. What it would say is, how do I train my yellow lab to, I don't know, close the door? Which he actually does, which is fascinating. Sidebar.
We need to see a video later.
Okay, I will show it to you later, I promise. So how do I teach my yellow lab to close the door? What it will do is it will go into all the different pieces of documentation that you have, and it'll find the closest thing to that sort of what I call like topic address. So maybe things that are in that area are, special tricks, unique tricks, like something about a door, things that are in that semantically similar space. The way we do that is something called Cosine similarity. big fancy math, but basically it says what is closest to this address of this question, right? In these spaces. So in GraphRAG, we start with that. So we say, okay, I ask how I do that, and then it will go to those document chunks or those little pieces of information that are really similar. We know, though, as human beings, let's just say I'm the new person at work, and I am going to use retrieval augmented generation to answer a question about how do I do this task at this company.
Right.
It's almost like the visualization I like to use is, so imagine if you had a bunch of index cards. So every one of those little chunks of information is an index card.
Right.
And if I ask a question and you give me the index cards that have the closest to my question, it'll give me some information, but I don't know how it fits. Like maybe I know it came from an HR document, or maybe I know it came from product documentation, but I don't know how it fits together.
Right, like this index card that I have to answer the question, in some ways is helpful, but if I also knew which other index cards are tier 1 to that, then tier 2 to that, then it gives, again, like it gives me a better understanding of the one index card.
Exactly. So in GraphRAG, what we do is we go to your chunk, your vector, your index card, and then we say, what else is it related to? So maybe if certain cases, one of the ones that I use a lot is financial documentation, right? So SEC filings, and I can say, what are the risk factors that Apple is facing right now? I can go in and, if I've got that as a relationship, I could do risk factors. If it's semantics, I can go into the document. But what if I'm concerned about entities that own that Apple stock? So if I say, which fund managers are most impacted by a lithium shortage, I can go into those SEC documents of those companies and find that information, but I need to have a structured connection to who owns stock in those companies. So what GraphRAG does is it allows you to anchor in semantics and traverse across structure to get the full context of your answer you're looking for.
Right. Yeah. And I'm also, and this is more off the cuff, but I'm also thinking it's just actually using LLMs to their full potential too, right? Fundamentally, using just RAG on a tabular database for LLMs is not actually using the full potential where they can operate with the GraphRAG in place, which gives that context meaning and the connections to them too.
Yeah.
So you can also improve the usage of the tools you're building on top of it.
100%. 100%. And there's so many interesting ways that you can use the LLMs. I know we're doing it in the Build-a-thon today, using the LLMs to actually create the graph. Yeah. How do we extract structure from this unstructured form? Right? So there's that interesting element, and there's the connecting to the structure that you actually have. So all of that together creates a really rich environment for using our natural language to really surface actual contextual information.
I'm curious, have you had I don't know if you've had a chance to look at the projects from today? Not yet?
I have.
You have?
I have.
Yeah.
I saw when they were released.
Any particular ones that caught your eye or would really be, using the power of GraphRAG?
I mean, there's one that's really specifically focused on actually doing that. And I think for most people, I would recommend actually starting with something like that, because the thinking in graph takes time. Like it's a context shift, right? And so I really encourage people to start with really obvious projects with graph to just start to get you thinking. Like when I do workshops, it's always about, okay, think about your data. What are the natural connections? And it just takes time. And so starting with that structured project of, let me do this thing, I think is a really great way to just get into the world of connection.
Yeah, do you have maybe we could work through a quick example of something, if folks, let's say, didn't have a project of their own, but wanted to implement a simple project just to start using it, what could be a sample for them to get going?
Yeah, I'll be honest with you, I love GraphRAG, and I think it's, I know we've talked about it a lot, but it's a really great place to start. I think more important than having you should try this first, it's to there are a couple of key factors that pop up that let me know that maybe graph would be helpful here.
Oh, okay, yeah, that's a good point.
And one of them is
being able to recognize that.
Yeah, so it's really good at many-to-many relationships.
Okay. Yeah.
Right?
Right.
So anytime you have complex connections and complex intertwining, so many to many is usually a good place.
Yeah.
If you have something where the sequence is important and the sequence could change or could veer in different places, think, our Waze app or your most interesting route to work app.
Yes.
So pathways are important. And the other thing is anytime that there may be non-obvious communities. So those are usually the first three that come up for me.
Just to summarize, so if there's many to many, if there's a kind of a pathway aspect to it, and if the last one was if there's certain communities, kind of like in fraud, the use case
the non-obvious community.
Interesting. Yeah. So when you see that in your use case, and that's when it kind of jumps out like, hey, maybe now is the time to be thinking beyond just tabular, like moving into that.
And that's why the agentic space is really interesting for me, right? Like we talked about already, is moving around the tooling, moving around the agents. What are the choices they're making? What are the pathways that they take? Because it actually becomes really interesting to product development. Right, for all of the folks who are building these agentic tools, building AI employees, right? The understanding of what those pathways look like in the product itself can actually teach you a lot about how you want to mold it. So there's some really interesting things to be done there
I'm curious if you can speak a bit more about how has Agentic kind of played with GraphRAG, because I know there's, agentic at the end of the day is such a broad term.
Yeah.
It can mean a lot of things.
Yeah,
so I'm curious if there's a certain specific example to, again, ground our discussion that's really been foundational.
Yeah, I mean, we have, obviously we have an MCP in Neo4j MCP server.
Okay.
But for me, and again, this is my personal opinion, is it's really about the movement and the physics of the agentic decisions that are being made that I think is the most interesting graph moment. So if you take, say, your OTel telemetry data, graph your OTel data, super interesting. OpenTelemetry. So something like, I know Dagger, Hypermode, a number of the different agentic frameworks have OTel like telemetry built in. So, and certainly there are companies that are focused on leveraging that, but even just in your own aspects, drop it into a graph and look and see what naturally comes up. So do you see common pathways? Do you see those moments of AI density in the tooling?
Yeah.
Right? Those are the things that I think are the most fascinating.
This is, again, tangential, but I'm just going to throw it in there.
Yeah.
I've been reading the book 1,000 Brains. I think it's Jeff Hawkins. It might be wrong, but I'll look it up.
Yeah.
And it kind of alludes to how our brains have been very much structured around the concept of movement. So I love when you're mentioning that, because even our brains are at their core, all concepts are built around the concept of moving from one place to another, because that's where we evolved from, is understanding moving as a thing for our...
now I want to read this
book.
book.
My God,
You'll have
it's
to
amazing.
send it to me.
Yeah, and it really builds on this idea that that's a fundamental building block for, so to speak, our neurons connection, is the concept of physical movement, but then that was the building blocks for all types of thinking. So if you're thinking about kind of apple, red, you're moving through those spaces and you're actually using those neurons.
Yes.
Which is what I love about kind of graph.
The graph pathways, exactly.
Oh, yeah. Oh, yeah. Okay, so I'll send you that. But it was just fascinating. Even as you're talking, I was making that connection.
See, it's all about connections. Movement. You're building your own graph of the conversation, right?
I know, yeah. Oh, we got to go back to our demo of as you have the conversation to build.
Yes. To fill everyone in, we were having a conversation this morning as we were prepping for this, where we thought it would be fun this afternoon potentially to build a live graph build of the conversation as a visual to go with it.
Right.
So,
I think there's something there.
I've got some time this afternoon. Maybe we can hack it out.
I know. So I think going back kind of to Neo, I'm kind of curious when what are some examples of deployments that have been really successful and exciting? What are some of the current things that are happening Wanted to go back and see
So
if
many
there's some
things.
examples you can share with the audience.
Yeah. Obviously, some of the things I mentioned already, fraud detection is a big one. Recommendation engines are a really common piece for us. IT implementations for tracking networks, IT networks and things of that nature, cybersecurity. Some of the things that I think are fascinating is work that's done in bioscience and in the biomedical space. So drug discovery. So if we think about that community concept, right? The community of proteins, diseases, and drugs, right? So now you can find potentially something that isn't obviously connected, but maybe one hop out and maybe impactful. So that is something that happens a lot of time when we think of off-label use. Someone will be seeing a secondary effect of a drug in some sort of clinical trial or even in practice, and then that becomes the next element for that. So rather than waiting to see, we can start to see these communities, we can see these connections, we can see these tangential effects, and use that to start to look at interesting and novel either applications of those uses or potentially new ways of addressing something. We know this protein responds to this chemical this way, this tangential thing does that. What now becomes possible? So oftentimes what we find is once you start putting something in a graph, the graph itself becomes the collaborator.
Right. Yeah, it's like kind of an active participant in giving insights to the project.
I mean, and this is where the agentic moment and the generative AI of actually interacting with the graph and asking it to, look at this graph and show me what might be interesting or what might be new. Right. So the data itself and the structure itself becomes part of that natural language collaboration.
Wow, I love that. Well, I know we're coming up at time, so anything else that you think the audience should know either about what we've discussed or about Neo that you'd be
graphs are great. Everything's connected, cool. Obviously. No, but the other thing that personally I'm really interested in and where I think we're going is a concept of control native AI. And I think as builders, a lot of times what we see is guardrails that come in after the fact. And we're limited by, you think about testing, right? Test-driven development. We have to consciously think of, what might be an edge case? What might come up, right? Now with, AI-assisted coding, we can move into slightly different spaces, but we haven't had that same moment with guardrails. So guardrails are still very much, we put them in once something has already gone wrong. And so we have to create the bounds after the fact. And what I'm really interested in, like some of the work that Anthropic does on steering and mechanistic interpretability, just makes my intellectual heart so happy, because it is about that steering moment. It is about how do we build that inside? How do we allow, the analogy I like to use, and I know it's a lot of words, but the analogy I like to use is AI tools are like bowling balls, right? They're big and they're heavy and they're powerful and they have this one thing that they're going to do and they do it really well, right? Sometimes they hallucinate or they do something unexpected, they hit the gutter. Okay, we put the bumpers up, right? We put the bumpers up. But when we think about agents, what happens if the ball starts to actually come off of, it starts to levitate, comes off of the plane? Okay, well now we need to put in a roof, we need to put in a guardrail there, okay? Well, what if then the balls are agents and they start working together? And so instead of actually getting onto the bowling lane, they start connecting where, where they come out of the feed, right? You get a bunch of them and they say, well, the best way to do it is actually to just destroy the pins once and then we don't have to worry about it. They'll be done forever, right? All of that, then we have to wait until that happens to put the guardrail on. But imagine if there was a steering sensor inside of that bowling ball. If we could actually sense where it's going, we can see the directions that it's moving in real time and under real observation, right?
Interesting. So just so if I think about the analogy correctly, we're imagining the first example is we have to evaluate where the bowling ball would go or what are the guardrails we need to put in place. That's one approach. But the second approach you're highlighting is instead of looking at it from an observer standpoint, you're actually inside of the bowling ball as, like, let's call it the agent itself, or the traversal mechanism, and being able to notice when it deviates from the prescribed parameters, and then you're more proactive in your guard creation.
Exactly, right. So the idea is emergent behavior identification in real time.
Right. Huh. Yeah.
So that's where my personal research and joy goes. So, you know, if anybody's curious about it, follow me on LinkedIn. We're happy to talk about it anytime. I'm so, like, I love technology. I love where we're going. I love this moment so much. And I just think there's so many people, even people here in this room especially, who are doing such incredible things. And it's super exciting.
I love it. Well, that was a great conversation. And we're going to be taking a short break, and we'll be back with some chats with some of the folks working on the Build-A-thon in a few minutes. Thanks, everyone.
Thank you so much.